After completing this chapter, the learner will have a clear understanding of flammability in respect of hydrocarbon gas-air mixtures. Know the flammability limits and range for hydrocarbon gas-air mixtures. Know the principles of safe dilution of atmospheres containing hydrocarbon gas-air mixtures. You should already be aware of the fact that fuel will burn in the presence of sufficient oxygen if an ignition source is present. In this module, the fuel that we are considering is hydrocarbon gas, principally from oil cargoes carried in tankers. As the gas mixes with the air in the ullage space of the cargo tank, the formation of a flammable mixture is possible. When a substance or mixture can be ignited and combustion occurs, the substance is said to be flammable. It is worth noting that the terms flammable and inflammable have exactly the same meaning. To avoid any confusion, we will use the term flammable and its derivatives in this module. The oxygen content of atmospheric air is normally taken to be 21% by volume, with the remainder being nitrogen plus very small amounts of other trace gases such as argon. For our purposes, we will take the nitrogen content to be 79% by volume. If we consider the space above the oil in a cargo tank, it will contain atmospheric air and hydrocarbon gas. The proportion of atmospheric air present will depend on the proportion of hydrocarbon gas in the mixture. As the proportion of hydrocarbon gas increases, the proportion of atmospheric air, and therefore oxygen, will decrease. A flammable mixture can only exist if the concentration of the fuel is within certain limits, which depend on the actual fuel being considered. We refer to the maximum concentration of fuel as the upper explosive limit, UEL, and the minimum concentration of fuel as the lower explosive limit, LEL. A flammable mixture can also only exist if sufficient oxygen is present in the mixture. Click on the buttons for more information on explosive limits and oxygen requirements. When inert gas is added to the mixture of hydrocarbon gas and air in a cargo tank, it has the effect of reducing the upper flammable limit and increasing the lower flammable limit. It also reduces the percentage of hydrocarbon gas and oxygen in the atmosphere. Any point on the diagram to the left of line AB represents a mixture of hydrocarbon gas, oxygen, and inert gas, which includes nitrogen from atmospheric air. The area enclosed by the curve CDE is the explosive or flammable range. At any point within this range, the mixture is flammable. In the area above the range, the mixture is over-rich, and below the range it is too lean. To the left of the range, the mixture has insufficient oxygen to support combustion. As stated, any point on the diagram represents a mixture of hydrocarbon gas, oxygen, and inert gas. If we consider a point F with hydrocarbon gas and oxygen content as indicated, we can see that it is outside the flammable range, and therefore the tank atmosphere can be considered safe with regard to explosion risk. Whether or not the tank remains explosion risk-free depends on how we carry out further operations. Consider again the point F. If we now wish to gas-free the tank following discharge of the cargo, that is, return to 21% oxygen content with no hydrocarbon or inert gas content, you may think we can achieve this by diluting the atmosphere with fresh air. During such an operation, the atmospheric makeup of the tank will change, as indicated by the line FA. You can see that the operation will take us through the explosive range, and this is obviously not desirable, as we introduce a risk of explosion. It is only safe to dilute the tank atmosphere directly by air if the path of the entire operation passes below the explosive range. The upper limit for this type of operation is shown by the critical dilution line. We can purge a cargo tank by further adding inert gas, which will reduce both the hydrocarbon gas content and the oxygen content. Gas freeing should always be carried out in such a way that the tank atmosphere is never in a flammable condition throughout the operation. The first step in the gas-freeing operation is to purge the tank with inert gas until the makeup of the atmosphere is at a point below the critical dilution line, as shown by line FH on the diagram. Once we have reached this condition, dilution by fresh air can be carried out until the tank atmosphere is free from both hydrocarbon gas and inert gas. This part of the operation is illustrated by line HA.